as the acute angle theta prime, that's what that little apostrophe is and how we read it, formed by the terminal side of theta and the horizontal x-axis. So by definition, that is what a reference angle is. A reference angle should be acute so that it matches up. I mean, it could be any angle, but if you're going to evaluate something without a calculator, it should match up to a 30, 45, or 60 degree angle, because then you know the ratios of the side lengths in those special right triangles. A key piece to the definition for reference angle is that it's formed by two parts on the coordinate plane. The terminal side of the angle, so wherever that opens, and the horizontal x-axis. The most common mistake that I see when we first learn reference angles in Algebra 2 is a lot of times you'll just go back to whichever axis is closest, and so sometimes that will look like the y-axis. So sometimes people find reference angles using a y-axis. That's not an actual reference angle. And that goes back to the idea that the reference angles should be one of those triangles that form that bow tie or butterfly shape we talked about when we took notes on Friday. Okay. So if you kind of pay attention to those triangles there in the coordinate plane, they all have right angles at the horizontal x-axis. So you never actually want to draw back to the y-axis, okay, because then that's where your right angle would be, okay? Also note that you really only use reference angles when you're working in quadrants 2 through 4. If you're in quadrant 1, your angle or a co-terminal angle will be acute already. So then there's no work to do. Those are really nice angles to find. Anything in quadrant 1. So we use reference angles for things that are greater than 90 degrees. Angles that are in quadrant 2, quadrant 3, or quadrant 4. Now I'm going to show you a visual of each of the different quadrants and what the reference angles will look like. This should look very familiar to you from your discussions of reference angles last year. The first one I'll show you is quadrant 2. This is an angle in quadrant 2. The angle is marked by the red angle theta. Okay, so you can see you have an initial side on the positive x-axis. The terminal side is opening up and landing in quadrant 2. Okay. And the reference angle I'll highlight in green using these pieces of my definition. I'm going to use the terminal side of the angle and the horizontal x-axis. In this case, I actually use the negative side of the x-axis. If I were to go back to the positive side, it would not be acute. It would be some kind of obtuse angle. Okay, so I have to go back to the negative side. And that angle right there represents what we would call theta prime, which is our reference angle. And so you can kind of imagine what that would look like then in quadrant 3. Here's an image of quadrant 3. Again, the red angle represents the original angle theta. Okay, the terminal side is landing somewhere in quadrant 3. If I use the terminal side and I form an acute angle with the x-axis, I would be going on the negative x-axis again, and there is my theta prime, or my reference angle, okay, for quadrant 3. And finally, in quadrant 4, we've got a larger angle so that the terminal side lands in quadrant 4. If I use the terminal side, and this time the x-axis, I'd have to go back to the positive. If I went back to the negative side of the x-axis, I'd be more than 90 degrees, so I wouldn't be acute anymore. So I've got to go back to the positive now. That would be my reference angle right there. So what I want you to do in your small groups is have a quick discussion about each quadrant. How would you calculate theta prime? So we're going to set up and write in our notes like a little rule or an expression so that I can always find theta prime in terms of theta. So in terms of the original angle, how would you calculate the theta prime, that reference angle? And in your groups, I'd like you to talk about not only in degrees, but also in radians. So you kind of have two expressions per quadrant. Okay? If you're having trouble coming up with one of the rules, then I would suggest like pick an angle, like if you're doing quadrant 4, pick an angle measure that is in quadrant 4, like 300 degrees is in quadrant 4. So if you have a 300-degree angle, how would you find that little reference angle? Okay, and that should help you kind of formulate what that rule might look like. So if you would go ahead and have a discussion really quickly for quadrant 2, 3, and 4. What does your rule look like? I'm going to call on you in a couple minutes so you can share your answers.
1 Q theta plus theta minus
Do we need any more time? We're ready? Okay, Haley, tell me what your group said for quadrant 2.
For quadrant 2, we said 180 minus theta or 2 pi. Not 2 pi, pi minus.
Very good. 180 minus theta, or in radians, that would be pi minus theta. I mean, you can see there when you look at quadrant 2, the red angle and what I have labeled as the green angle, they are adjacent angles. They form a straight line. That's kind of like a linear pair in geometry, so they have to add up to 180. If you knew one of them and you wanted to find the other, just subtract the one that you know. Okay, so pretty basic. And then if it's in radians, just use pi instead of 180. Courtney, do you guys have a rule for quadrant 3? Theta minus 180, so the original angle minus 180, or theta minus pi, just pi, because that's equal to 180. Good. So in that one, I always think in quadrant 3, it's like you're finding the overflow. So you have gone way beyond 180 degrees to get somewhere in the third quadrant. And so you really want to subtract those first two quadrants 180 degrees so you can just calculate what's the overflow of that 180 degree angle. Okay. And Nick, can you tell me the rule for quadrant 4?
360 or 2 pi minus theta.
Very good. 360 or 2 pi minus theta. This one, again, is very similar to quadrant 2 because you see that the two angles theta and theta prime form a complete revolution. So instead of adding up to 180, they add up to 360. Okay, excellent. Okay. Now, note that these rules, the way you do this subtraction, this only works if theta is between 0 and 360 degrees, or theta is between 0 and 2 pi. Of course, if we're working with number or angles that are negative angles, or we're working with angles that are greater than 360, those rules won't necessarily calculate our exact reference angle. So in thinking about that and what we're going to do on our next slides for our examples, if you have an angle that isn't between the 0 and the 360, find a coterminal angle first. So use a coterminal angle to address any angles that don't fit in those realms. Now, I will say just really quickly, notice my inequality signs right here. I've got less than or equal to, and then just a less than. That will come in handy for some of our later problems. Like, I might say later, like, I'll give you a trig ratio, and I'll say, tell me the angle on the unit circle. For the most part, we only have one angle measure at each of those points on the unit circle, except for at 0, right? We know that that's 0 or 360. 0 or 2 pi. If you ever want to talk about that angle as an answer for me, I want you to give me 0. So that everybody's answers looks the same, we say 0 instead of 2 pi. So if your instinct is to say, oh, that's a 360-degree angle, know that you're actually going to give me the answer 0. Okay, so here's practice with just reference angles. So it is a skill you should have. You should know about reference angles. On the next slides, we're actually going to kind of like go over the reference angle, skip over that step, and just utilize our unit circle. Okay, so it's actually going to be a shorter version coming up. But here we just are like reviewing what a reference angle is and how we can find it. So I have theta equals negative 225 degrees. Can you sketch that angle in standard position? Would you be able to do that? Yeah. I mean, I can even sketch it as a negative angle, correct? I'm thinking negative angles move clockwise. So here's 0 degrees on my positive x-axis. I'd have negative 90, negative 180, and negative 270. And so I now know my terminal side must lie somewhere between negative 180 and negative 270. So I'll keep my initial side on the positive x-axis. Put my terminal side in quadrant 2. And that represents my angle theta. So I've sketched the angle theta. And by doing a sketch of the angle, that makes it really very clear for you in terms of like calculating your reference angle. Will you be doing 180 minus the angle minus 180, 360 minus the angle? Because it's in quadrant 2, we want this little piece right here for theta prime. And so we talked about you would do 180 minus the angle. Only issue here is if I were to do 180 minus negative 225, am I going to get something that is acute? No. So instead of using negative 225, which is a negative angle, find its coterminal angle. How could I find a coterminal angle? Sammy, what do you think? Add 360. Okay, so find a coterminal angle, add 360 to that 225. That should get you to 135 as a coterminal angle. And then if you do 180 minus 135, you now know that your reference angle is 45 degrees. So this work should seem familiar to you from Algebra 2. Okay. You drew the angle, you found the coterminal angle, you found the reference angle. At this point, I could then ask you, like, what's the sine, cosine, or tangent of negative 225? And you would, in Algebra 2, you would have drawn the triangle, the 45-degree triangle. You would have done opposite over hypotenuse or whatever you wanted, and then you do all students take calculus to figure out positive or negative. Again, this is going to be a point where we jump to the unit circle, so we avoid all of that because we have the unit circle. Okay. One other example that I want to show you just in terms of graphing radians, I think this is a challenge for some people, so I'm going to do another example where I show you how I can think about graphing something in radians. So if theta equals 17 pi over 3, how can I graph that? Well, when I'm graphing things in radians, I think mainly, to start with, about pi and 2 pi. And so then I try to figure out, like, where is that angle in terms of pi and 2 pi? Well, 17 divided by 3 is much larger than 2. Okay. So if I think about 2 pi as a denominator of 3, that's really 6 pi over 3. That would be the same as 2 pi. And so in order to draw that angle, I'd have to go around one full time to 6 pi over 3. And then I'd have to go around again, which would get me to 12 pi over 3. And then I wouldn't want to go all the way around because that would be 18 pi over 3. I want to go 1/3 less than that. Okay. So in terms of my angle, I'm going to do the spiral piece first. I'd go around once, that's 6 pi over 3. I'd go around again, that's 12 pi over 3. And then I really only need an additional 5 pi over 3, which you're familiar on the unit circle lands in quadrant 4. Okay, or you could think about it, it's 1/3 less than the full revolution. Okay, and so when I draw that angle, my initial side is on the positive x and my terminal side is in quadrant 4. In order to find my reference angle, because I'm in quadrant 4, I'm going to take that full revolution of 2 pi and subtract the angle from it, but I can't do 2 pi minus 17 pi over 3 because then I'll get a negative angle. Negative angles are not reference angles. So I would utilize coterminal angle again. Okay. What's nice about graphing this one is because I went around 2 full times and then graphed an angle, I know that I'm going to have to subtract a full revolution twice. So I'm going to subtract 6 pi over 3. That will get me to 11 pi over 3. Subtract 6 pi over 3 again, and then that gets me to 5 pi over 3, which is my coterminal angle. Okay. So subtract 5 pi over 3, and you have a reference angle of pi over 3. Now, you may have also had some discussions back in Algebra 2, like if I give you something like 21 pi over 4, what's its reference angle? Pi over 4. If I give you something like 723 pi over 3, what's its reference angle? Pi over 3. So, although that one divides nicely, so maybe it might be a pi or a 0. But anytime you have that fraction, you can kind of tell what the reference angle is going to be. Okay, so on a side note, be aware of that. That's kind of like a shortcut, but you should be able to think about it as full work. Any questions on sketching angles or finding reference angles? Take your time on those radians on your homework. I expect you to be well-versed professionals at graphing radians, thinking about radians, and all of those things. And the only way you get better at those is practice. Okay, so let's use things without a calculator. Yes, sir.
I was just going to ask when we're going to get the problems that it does.
Thursday. Evaluate without a calculator. The cosine of 8 pi over 3. Okay, so think about the quiz on Friday is going to be no calculator, calculator. I could ask a question like this on the no calculator piece. Okay, so you don't have a calculator, you don't have your unit circle, and I'm just saying, what's the cosine of 8 pi over 3? Now, compared to what we've done previously, a lot of people would be thinking, I don't know, 8 pi over 3 isn't on the unit circle, right? So what do you think we might do in order to be able to evaluate this? Find the coterminal angle. Okay. So this is larger than 2 pi. 8 divided by 3 is like 2 2/3. Okay, so let's subtract 2 pi from 8 pi over 3. Oops. Thinking ahead. Subtract 2 pi, which 2 pi with a denominator of 3 is 6 pi over 3, right? So I can kind of shortcut that. And so what it's really asking me is, in terms of a coterminal angle, what's the cosine of 2 pi over 3? Now, in Algebra 2, you would have found the reference angle, pi over 3. You would have drawn the 30, 60, 90 triangle, because that's pi over 6 and pi over 3. And then you would have done adjacent over hypotenuse. And then you would have done all students take calculus. In pre-calculus, you just say 2 pi over 3, what are the coordinates of that on the unit circle? X is -1/2. Okay, and y is positive square root 3 over 2. And then we know on the unit circle, cosine is always x and sine is always y. So to answer that question, we would just say -1/2. That is so much faster than what we used to do in Algebra 2. Okay. But note that all of those things that would have happened in Algebra 2, you would have found the reference angle, you would have drawn the triangle, you would have done opposite of or adjacent. We have really already done on the unit circle. Okay, so that goes back to like that question Mitch asked about in the homework, and I said, if you pull out your pink triangle and you fit it to that 2π/3 angle in the second quadrant, you'll be doing the 60 degrees. And that will be its cosine. Can you evaluate this one for me, please? The secant of -480? If you add 360 once, it's still negative. So you gotta add 360 again. What is your coterminal angle? 240. So we're doing the secant of 240 degrees. And then you can jump to your unit circle. You know, at some point you won't need the whole coordinate. Just depends on how familiar you are with the unit circle. You know, I think about 240, it's in the third quadrant. It is the, 4π/3 angle. So it matches with π/3 in the first quadrant, except for that both of its coordinates are negative. So it'd be -1/2, -√3/2 for the coordinates of 240. And then if I want to do secant, which one will I be looking at? The cosine, and then I will flip it. So my answer should be -2.
Would you need to write the answer as you can have the 240, or could you go back to the original problem?
You could go back and you could say the secant of -480 is -2. Yeah, either one is fine. Any questions about that? Note that even though we're studying reference angles, we're kind of skipping over it right here because, like I said, we've already done all that work on the unit circle. We did the reference angles as we went around. Okay, there are a couple of other examples on the homework assignment, and they will be similar to something like this. The top part just gives you like the directions, and you'd read the same directions in your book, although I think this should not have an or equals. It should be like I wrote it on that other slide. Okay, so it's saying, you know, if I give you the trig ratio, so I tell you the sine of theta is -√2/2, tell me what theta could have been on the unit circle. And so you're thinking, what angles have sines that are -√2/2? What quadrants are they in?
3 and 4.
Quadrant 3 and quadrant 4, because if your sine is negative, you're going down, right? And what are those angles?
225.
225 and 315. Okay, so you would answer 225 degrees and 315. And it says give your answer in degrees and radians. So then this is a great problem for you to do for homework because you get extra practice matching up your degrees and radians. 225 is 5π/4 and 315 is 7π/4. So you're working backwards. I give you the ratio and you tell me what it could have been on the unit circle. And there should be 2 answers. Any questions there? Can you do one for me? Do the tangent of theta is undefined. I want your answers in degrees and radians. lean across the aisle, tell the people what it is. What angle?
Oh, yeah, I did that right.
Correct answer should be 90 degrees, 270 degrees, and then pi over 2, 3 pi over 2. Okay. So you're thinking about tangent on the unit circle. Remember, tangent on the unit circle is y over x. So you would need your x to be 0 so that it comes out to be undefined. And those are the 2 points where you go 0 left or right, straight up and down. Okay, good. Your homework assignment is here. It's also on your goal sheet if you need it. Please make sure that you do the homework assignment. On tomorrow, we're going to do more section 4.4, and then Thursday is going to be review. Halfway through class on Thursday, I'll pass out the problem set, and the problem set is a one-day turnaround this time. So, the problems don't take very long, but make sure that you're doing them now so when I'm reading answers, you know if your answers are right or wrong for the problem set. Okay, so I've given you all the answers so far. Everybody should know if their answer is correct or incorrect when they get to the problem set. The only people who don't are people who don't do homework. Shame on them.